The James Webb Space Telescope, a one-of-its-kind masterpiece, a multi-billion-dollar project and the biggest telescope ever in space, has finally begun taking action after about 1.5 months of its nerve-wracking launch on Christmas 2021. The telescope that is built to look as far as 14 billion years into the past, to the point in the evolution of the universe when the first stars were being formed. James Webb Space Telescope is going to unravel the hidden truths of this massive universe. To do so, it has to perform perfectly up in space, just like its perfect launch and unfolding. And now, all eyes are set to just one thing: the first detection by this masterpiece. Keep watching till the end to find out all about the first discovery of the telescope Paragon. Everything about the James Webb Space Telescope, from its conception to its launch, has been nerve-wracking for the scientists over at Northrop Grumman and around the world. After the successful launch of Christmas 2021 from the Ariane Launch Complex 3 located near Kourou, French Guiana in South America, many thought that the most difficult part had been done, but that was just the beginning. The time of sleepless nights began when the telescope started its 29 days of space origami. Bill Ox, Webb Project Manager at NASA's Goddard Space Flight Center, Greenbelt, Maryland, said, "When I started out in this business 40 years ago, the first lesson I got taught was to avoid deployments in orbit, but Webb can't avoid it. Webb will have to perform some of the most complex deployment sequences ever attempted. They knew what they have been building and what's going to take for it to be fully functional in space. Now the telescope has arrived at its destination after traveling 1,000,000 miles, where it has begun the process of cooling down, calibrating its mirror and instruments, and detecting the first light. First light is an important milestone for any telescope, as it is the point where starlight is detected by the observatory and its various instruments. Through this, the observers can enable a months-long alignment of the telescope. Webb's first light came from a star known as HG 84406. It is a sun-like star and is located 241 light-years from Earth and part of the constellation Ursa Major, the Great Bear. Now, if you think that Webb has started taking pictures and began a new era of space observations, then that's not the case. These images are not going to be used for research purposes. Rather, they're going to help Webb's mission control team to align the 18 golden segments of the telescope's 21-foot-wide, 6.5 meters main mirror. So these images are not the way we expected the telescope to show us, but it's exactly what NASA had expected, and over time, it will be able to adjust to segments to bring the image into focus. NASA Webb Telescope on Twitter posted, "Our NIRCam instruments detectors saw their first photons of starlight. While NASA Webb is not yet ready for science, this is the first of many steps to capture images that are at first and focused used to solely fine-tune the optics." HD 84406 was chosen as a calibration target by NASA because it is moderately bright, located in an isolated area of the sky devoid of other bright objects, and was ideal for JWST's first light. Calibration is now the most important part because it is a part that will lead to some of the best images from space. Now, just as it took time for any other aspect of the telescope, the calibration is also going to take time. This is because of the size of Webb's mirror, which is 273 square feet, 25 square meters, but more importantly, the segment style that consists of 18 individual honeycomb-shaped mirrors that are going to be one large sunflower. John Mather, a Nobel laureate and astrophysicist who also works at NASA's Goddard Space Flight Center in Greenbelt, Maryland, said, "First, we have to find the images that all of those 18 different hexagons are making, then figure out which one is which, and then start sending commands to the little motors that move the viewers around to get them in the right place." When the scientists were performing the calibration of James Webb's predecessor, the Hubble, the iconic observatory that has been operating for 30 years, it was not what we are yet to witness with the James Webb. Hubble's primary mirror has a total surface of around 48 square feet, 4.5 square meters, and that's way smaller than the Webb. Even though James Webb is going to take time, it will be more reliable than the Ritchie-Chrétien reflector from Hubble. After all, we have come a long way since Hubble was designed in the 1980s. Hubble had a problem with that single hyperbolic mirror, which necessitated a servicing mission to fix an optical flaw. With Webb's adjustable segments, this shouldn't be an issue. Now, over the following 3 months, NASA will nudge each of the gold-coated beryllium panels into place, reducing 18 points of light to one giant sunflower. In an update, NASA said the early engineering imagery produced during this stage in the process, called segment image identification, stitches together more than 1,000 images to form 18 unfocused versions of a single star. This serves as the starting point for gradually aligning Webb's mirror segments into one precise system. Once complete, Webb will be ready for its mission to peer deeper into the universe than ever before. But there is something that needs to be attained before the telescope can start its function. With that, we have come to the end of our video. We hope you enjoyed it and learned something new. If you did, make sure to hit that like button and subscribe to Curiosity Lounge so that you never miss any amazing video from us.